Since students all over the world are studying for calculus AB, AP exams, I thought I'd go over a calculus AB exam problem. This one is a non-calculator problem, and it says the continuous function f is defined on the interval -6 to 5. The figure above shows a portion of the graph of f consisting of two line segments and a quarter of a circle centered at the point 5, 3. It is known that the point 3, 3 minus root 5 is on the graph of f. For part A, it tells you that the integral from -6 to 5 of the function is equal to 7, and it wants you to find the value of the integral from -6 to 2 of the function. And it asks you to show your work. So what it's asking us is the integral from -6 to -2. And if you look at the graph, we're not given that piece. That piece is over here somewhere. This is, let's let this be -3, -4, -5, -6. So they want the area under the curve from -6 to -2. And they give us the area under the curve of f from -6 all the way to -5, to +5. So what we can do is use properties of integrals to split this integral that we're given, integral from -6 to 5 of f of x dx. We can use properties of integrals to split this integral up into two integrals. One that'll go from -6 to -2, and one that'll go from -2 to +5. And then this will allow us to calculate what we need to find, which is this integral. This is what we're looking for. And we can calculate this piece by just using the graph. So we'll talk about this once we get there. And this is the piece that we're given, 7. All right. So just having that information that the entire integral from -6 to 5 on its interval is equal to 7, and we're being asked for the portion that's not given with is not graphed for us, and the portion that is graphed, that's going to help us figure out the portion that's not. So 7 is going to equal the integral from -6 to -2 f of x dx plus the integral from -2 to 5 of f of x dx. We can move this piece over to the left of the equation. So we have 7 minus the integral from -2 to 5 of f of x dx is equal to the integral from -6 to -2 f of x dx. And now, as long as we can figure this out, we will know the integral from -6 to -2. So let's start taking a look at the graph and trying to figure out what this integral is. So I'm going to erase a couple things here to make some room. Let's erase this piece. I think we understand that piece, so we don't need to keep it there. So remember, integrals represent area under the curve. And when you have the area above the x-axis, it's going to be positive area. Any area below the x-axis will be negative area. So looking at this graph, the area under the curve, I'm going to shade it in. Right here, we've got area under the curve. Let me use a different color for the negative area. We've got this piece, and we have this piece. All of that. So that's what this integral is going to represent. It's going to represent these two green pieces and plus this orange piece. The two green pieces are going to be positive area and the orange piece is going to be negative area. So now let's start breaking it up and figuring out what is that area. What's great about this problem and this graph is that the area here we can calculate just by using geometry, right? So if you look at this little piece right here, this is just a triangle, not a rectangle. This is just a triangle with height 1 and base 1. And we know the area of a triangle is equal to 1/2 times base times height. So here, the area of that little green triangle is just 1/2 times 1 times 1, which is just 1/2. So that's the first piece. Now, if you look at the next piece, I'm going to break up the next piece into what looks like another triangle. And this one, I'll just draw it right here, also has base 1, height 1. So the area of that little pink triangle is also going to be 1/2. But it's below the x-axis, so it's going to be negative area, negative 1/2. And we keep going like this. Let's look at the next little triangle. The next one is going to look like this. It's got height 1, base 1/2. So this one's going to have area equal to 1/2 times 1 times 1/2. And that's just 1/4. And remember, it's negative because it's below the x-axis. So this little teal triangle is negative 1/4. And let's continue. This is the next piece. That orange triangle has base, this is 1.5, so 3/2 for the base of that triangle, and then 3 for the height of that triangle. So the area there is going to be 1/2 times 3/2 times 3, and then that's just 9/4. It's positive because that triangle is above the x-axis, so plus 9/4. One more little piece that we need to take care of, and I'm going to just erase this a little bit to make room. The last piece we need to consider is this little piece right there under that curve. This piece, this red piece, is no longer, so we're not doing triangles anymore. This part is in fact a piece of a circle, and a circle has a specific equation. So what we could do is write the equation of that circle. We're given the center of the circle so that we can use that, and we're given a point on the circle. We could also use that and write an equation of a circle and then do the integral from 2 to 5 underneath that function. But another thing that you could do that is a little bit more creative and kind of more fun, I think a little bit more fun, is you could use geometry this sort of the same way that we just did with, not exactly, but kind of use the geometry that we see here and figure out the area from geometry. So the way that I want to do this is to find the area of this square, which is a 3 by 3 square. So the area of that red square is 9. And I want to subtract off the area of a fourth of this circle, and then that will give me the area of the piece underneath that fourth of a circle. This circle has radius 3. I know that because the center is given as 5, 3. And so if I'm just looking, what is the distance from the center to some point on the circle? This would be one such distance that I could, this is one such point on the circle, and so this distance here is, we can see from the geometry, it's 3. So that's pretty simple. The area of a circle is pi r squared. R is 3, so the area of the entire circle is going to be 9 pi. But for that green portion, that's going to be 1/4 of a circle. So the area that we want to subtract off from 9 is going to be 1/4 of 9 pi. So that is going to be the little piece underneath that portion of the circle. Plus 9 minus 1/4 times 9 pi. And from there we can simplify. 1/2 plus negative 1/2, those will cancel out. Negative 1/4 plus 9/4, just add the numerators. Negative 1 plus 9 is 8. 8 divided by 4, it's just 2. So we've got 2 here, plus 9 minus 1/4 9 pi. 2 plus 9 is 11, minus 9/4 pi. That is the area under the curve from -2 to +5. So we're really close here now. Now we just need to do 7 minus the area under that curve, and then that's going to give us what we're looking for. So 7 minus this piece is equal to 7 minus 11 plus 9/4 pi. That's equal to -4 plus 9/4 pi. And so our final answer is 9/4 pi minus 4. That's our final answer for part A. All right, if you want me to continue on with this video and do another one for part B, C, and D, comment in the section, comment below, let me know. This video is turning out to be pretty lengthy, so let me know if you want me to do B, C, and D, and I can do separate videos for those.